Good afternoon, everyone. Thank you for joining us today. Dear colleagues, welcome to this seminar, Organising Resistance in Science, which is part of our BrIAS seminar series on democratic governance. Our guest today is Professor Naomi Oreskes, Professor of the History of Science and Affiliated Professor in Earth and Planetary Science at Harvard University. Naomi, first and foremost, I'd like to thank you wholeheartedly for accepting our invitation. It's a true honor and a pleasure to have you with us here today. My name is Louise Knops. I'm Assistant Professor here at the University of Brussels in Environmental Humanities, and on behalf of the Brussels Centre for Advanced Studies, the BrIAS, as well as the Interfaculty Institute for Socio-Ecological Transformations of the ULB, I'm truly honoured to be able to give you a short introduction to this seminar. Naomi, it's probably unnecessary to introduce you, but perhaps not everyone knows how your journey began. You were initially trained as a geologist and then evolved throughout your career towards the discipline of history and philosophy of science, driven by fundamental questions such as, what is science? How does it work? How do scientists judge and evaluate evidence? How are facts turned into evidence, and why certain people resist and reject evidence? As a leading voice on the role of science in society, you have co-authored or authored 8 books, over 150 articles, essays, and opinion pieces, including the best-selling book Merchants of Doubt, co-authored with Professor Erik Conway in 2010. This has also made you a well-known public figure well beyond academic circles. The book unpacks the reality of anthropogenic climate change, the role of disinformation in blocking climate action, and crucially, how specific actors of the fossil fuels industry, among others, have constructed doubts and misinformation on climate change for decades. Your work shows us how to navigate the workings of scientific consensus, the necessary questioning, the contestation, the critique that is at the heart of scientific practices. It teaches us, crucially, that science, as well as the resistance against it, is deeply rooted in socio-historical and cultural contexts. Taking this into account is central to our scientific practices here too at the University of Brussels, in our commitment towards both scientific robustness and freedom. For all these reasons, it is fair to say that your work has become of crucial and urgent relevance today, at a time when the conditions under which knowledge, sciences, and evidence are built have become increasingly under threat, when misinformation and denial have become widespread in public discourses, and when the actors who perceive science as a threat have become increasingly powerful, and scientific resistance, therefore, an urgent mission. Resistance is a word that we have heard and used a lot in recent months, as fascist tendencies and far-right politics continue to rise. Corporate power consolidates, and scientists of many disciplines have become explicit targets of assault, in particular those engaged in the construction of disturbing truths which unsettle the current socio-political status quo. In this regard, your 2023 book, published with Professor Erik Conway, The Big Myth, How American Business Taught Us to Loathe Government and Love the Free Market, is particularly enlightening. It helps us, in particular, to interrogate and denounce the ways in which corporate myths take over science, and in this case, how the myth of the free market and the invisible hand has managed to remain a dominant imaginary, even despite the increasingly explicit failures of capitalism. Your work is thus of crucial value for all those who attempt to resist from their position as scientists and beyond. And your talk today, Naomi, is part of a series of events and lectures and seminars which we've organised at the University of Brussels throughout this academic year around the theme of resistance. In March 2026, we've had the pleasure to host Salomé Saqué, a French journalist who fights against the cooptation of media by the far right, among others, and who's a leading figure in the fight against misinformation, denial, and corporate propaganda. We've also had the honour to welcome Professor Bray, historian at Rutgers University and author of the New York Times bestseller Antifa, the Anti-Fascist Handbook, a book which has turned him into an explicit enemy of the Trump administration and forced him to escape the increasingly repressive and authoritarian context in the US. And today we'd like to carry on this discussion on resistance and science and the interrelation between those two. But who are we resisting against, and crucially, what for? being able to identify them, name them, as well as to identify a collective horizon for scientific practices and resistance is perhaps an urgent task ahead for anyone committed to science in all its sociocultural varieties. As your work teaches us, science is never neutral and is always politically contingent in the way it emerges, in the practices and networks of actors which make it visible, but also in the attempts to weaken it. Naomi, thank you again for being with us to address some of these urgent questions from your position, your experience, and your insights. Your relentless fight and determination in the defense of science, and in particular in the field of climate science, is an inspiration to all of us. Without further ado, please join me in welcoming Naomi Oreskes.
Well, thank you so much. It's really a pleasure and an honor to be back at the Free University and to have the opportunity to speak about these really urgent issues of our time. The only thing I can say is that, a lot of academics desperately want their work to be relevant. I desperately want my work to stop being relevant, but that hasn't yet. Okay, so obviously it's been not much in the news of late, the widespread attacks in the United States on scientific programs, scientific agencies, research universities, and of course, scientists themselves. So I thought I'd spend a few minutes just kind of recapping what's going on in America right now. I'm sure you're familiar with some of it, but I think the breadth and depth of it is worth stating for the record, and then do some work to try to put this into historical context, and then at the end of the talk, come back to some of the issues that I've raised in my books, Merchants of Doubt and The Big Myth, so then we can have a conversation about where this leaves us and what we might need to do. So, as many of you probably know, there have been massive cuts just in the last year or so to federal science. Many of these cuts done unilaterally, without congressional approval, and in many cases probably illegally, violating a number of laws in the United States. But nearly all the federal agencies that deal with science, including many popular agencies like NASA, the U.S. Geological Survey, the United States Forest Service, the National Park Service, even the Weather Service, which most people would think of as being not political, have seen massive cuts. And I'll get back to the Weather Service at the end because I think it's actually very important to understanding what's happening. There's been layoffs and coerced resignations of more than 30,000 federal scientists by the so-called Department of Government Efficiency. And I think it's very important to say so-called. It's not a department. It's never authorized by Congress. And of course, it had nothing to do with efficiency, because if you wanted to be efficient, you wouldn't just unilaterally sack 30,000 people. There have been closing down of entire institutions. Right now, the Trump administration is trying to close down the National Center for Atmospheric Research and attempting to sell off key public assets to the private sector. Again, another important part of understanding what's happening. And closing down scientific observing networks. Again, much in the news the last couple of weeks, the Ocean Observatories Initiative, which became operational in 2016. This is a $370 million network, so really actually not that expensive as these things go, which at various points in this talk, I'll make the point that this is not mostly about the money, although money does come into it. But $370 million is really not that much for a federal agency. I mean, just maintaining an aircraft carrier for a year costs more than $1 billion. But it's a network of more than 900 deep-sea monitoring instruments that are crucial to understanding how the ocean is responding to climate change. And this was specifically targeted in the Heritage Foundation Blueprint Project 2025 as a source of, quote, climate alarmism. So you see here facts or information being cast as alarmism. So the facts or the information being cast as a reaction. We've seen data erasure, whole web pages and data sets that have disappeared. Every time I go to a web page that I consult, I take a screenshot or make a permalink. So that's creepy to feel like you have to do that. And the revocation of a number of science-based policies and statutes, again, many to do with climate change, obviously withdrawing from the Paris Accords, blocking renewable energy projects, including some that were nearly complete, revoking tax credits for green energy, and my favorite, attempting to reopen shuttered coal mines and coal-fired power plants. And again, another piece of evidence that this is not mostly about the money. These are power plants that shut down because they were not economic, because they couldn't compete in a market-based system against cheaper natural gas and now cheaper renewables. So there's something going on here that is not just about the price of energy. So what is going on here? Oh, sorry, that's out of place. I should have had that first. Okay, so in addition to the direct cuts to federal science, there also have been cuts to federally funded academic work and partnerships. Again, many examples, but elimination of scientific assessments like the National Climate Assessment, obviously urgent for understanding how climate change is affecting the American people. A 42% cut in NASA's science directives, a $1.3 billion cut in EPA grants, elimination of the entire EPA Green Banking Fund, so intended to help communities or institutions or corporations to switch to more efficient or sustainable technologies. Ending the entire ARPA-E program, which was meant to be a kind of high-tech program to support funding for technological innovation related to climate, such as electric cars, battery storage, grid improvements, again, all things that benefit the economy. Major cuts or eliminations of various partnership programs, such as some of you may know CERES, the Cooperative Institute for Research in Environmental Science, and funding, withdrawal of funding and participation in the IPCC. So no federally funded scientists or scientists working for a federal agency is now allowed to participate in the IPCC. There's also been a kind of generalized harassment of academics and leading universities, including my own Harvard. So many of these budget cuts were focused and targeted at specific elite universities, most famously Harvard and Columbia. Harvard was the largest, $9 billion in cuts to grants, mostly at the medical school. So again, not necessarily just climate science. Demanding settlements, many of which were essentially little more than extortion, and some universities have paid settlements. Columbia paid $220 million to the Trump administration. Some people have called that a bribe. I feel like extortion seems more like it, because the administration is actually trying to get things out of the university, and one of the things it got was a promise to limit student protest. So while the universities are accused of being too political, we see these explicitly political demands being put on universities. And at Penn didn't pay money, but they agreed to modify their sports policies to restrict trans athletes in women's sports. And again, we could agree or disagree about that whole issue, but I think most people until this year would have said it's not the role of the federal government to decide how universities run their athletics programs. There have been moves to try to control hiring, promotion, admissions, and curricula. And then, of course, there's the issue of anti-Semitism, one which is personal for me. I went to hear the comedian Jon Stewart the other night. How many of you know him? He had a famous show in America called The Daily Show. And he was asked, aren't you worried about anti-Semitism? And he says, no, I'm not worried about it at all. Anti-Semitism is doing just fine. So I think the important point to make here is not to say there's no anti-Semitism. That's not true. Casual anti-Semitism has been common across Europe and the United States. I mean, I've lived in a lot of countries. I don't think I've ever lived anywhere where I didn't encounter some degree of casual anti-Semitism. But what Harvard is being accused of is very different, and in my personal opinion, completely bogus. More than a third of the faculty at Harvard are Jewish. The president is Jewish. This is an institution that had an earlier history of overt discrimination against Jewish students and faculty, but not in recent decades. But what we have seen, while the Trump administration is accusing institutes like Harvard of alleged civil rights violations against Jewish students, documented violations against Black, gay, trans, Muslim students, these go completely ignored by both the administration and the press. And of course, the continued structural racism and sexism, which many faculty and academics have written about, including through critical race theory, these go either unaddressed or even actively promoted. There's been overt censorship on pressure on faculty and students and federal scientists. So some of you may know the administration has issued directives in which they ban scientists from using certain words. So this is outright censorship, outright denial of First Amendment rights. So some of the terms that federal scientists are no longer able to use, or if you put them in a grant, your grant could be rescinded. Climate change, carbon emissions, carbon pollution, clean energy, diversity, including a colleague of mine who had a grant about biodiversity and coral reefs. So obviously they're just doing like AI checks and they find words and they get flagged, and even though the context may have nothing to do with racial diversity. Critical race theory, of course. Health disparities. A colleague of mine who worked on health disparities in endometrial cancer had to fight to get her grant restored after it was targeted. So we see this sort of overt suppression of language, complete elimination of programs related to mis and disinformation. That was completely canceled out. It was one of the first things the Trump administration eliminated at the National Science Foundation. And people who work on disinformation or misinformation, including myself, have been accused of violating the free speech rights of the people we study. So now if you study someone, you're somehow denying their rights. And my favorite part of this is that ExxonMobil has accused me of violating its First Amendment rights, which is pretty hilarious on a lot of levels when you look at what their budget for public relations and communication is and what my budget is. My budget specifically is zero. And also it's ridiculous because the First Amendment of the US Constitution is about what the government can and cannot do. It's not about what ordinary citizens can do. In fact, it's my First Amendment right to say whatever I think about ExxonMobil and to publish whatever our research findings show. But so you see this as a kind of, what they call DARVO, reverse victim and oppressor. Somehow we become the oppressors and ExxonMobil becomes the alleged victim. We've seen academic researchers have their notes subpoenaed, including communications with undergraduates. And the latest thing from the Trump administration, climate change is now referred to as the Green New Scam, so obviously countering the Green New Deal, and this is now official government policy. So you can find this term on government documents and websites, and of course the phrase clean coal, which is an oxymoron, has been restored to its former glory. Okay, so many of these things are things that if you've read my book, Merchants of Doubt, are not entirely unfamiliar, and particularly many of the ideas and many of the changes in language are being promoted today by groups that we have long studied for their role in climate change denial. So we're seeing many of the same institutional affiliations. The Heritage Foundation, we wrote about in Merchants of Doubt, Heartland, the Texas Public Policy Foundation, and the Committee for a Constructive Tomorrow, which I always want to say should really be the Committee for the Destruction of Tomorrow. So these are all familiar players, and the manipulation of language is something that we've seen before as well. In other words, most of the key players are not new, and many of the claims in language, particularly about climate alarmism, are familiar. But some of the tactics and the extremity of these tactics, the breadth and scale, are new and worrisome. And as I've already suggested, it's worth noting that many of these decisions make no economic sense. So often in the past, we would hear the claims that fixing climate change was too expensive or that renewable energy was too expensive. But now we're in a situation where renewable energy is now the cheapest form of newly installed electricity in the United States, and according to Bloomberg News in 65 other countries around the world, renewable energy makes economic as well as environmental sense. But that's not what this administration is doing. It's reopening closed coal plants and shutting down nearly complete wind power plants. And I just took this off Google, so it's in quotation marks. I didn't have a lot of time to work on this talk, so usually I would paraphrase things in my own words, but this one is so good I didn't feel like I needed to paraphrase it. So the Trump administration has spent approximately $2.6 billion in taxpayer money. And remember, that ocean observing network that they canceled was $370 million. $2.6 billion in taxpayer money to pay energy companies to cancel major offshore wind projects. So in other words, paying them not to build energy, but to stop energy. These deals include a nearly $1 billion payment to the French energy giant Total Energy, and hundreds of millions to developers like, I don't know how it's pronounced, Invenergy, to forfeit leases that they had bought to develop offshore wind. So this is a massive payout from the American government to corporations not to build renewable energy. Now, obviously, censorship, control of language, denial of scientific facts, these are all very Orwellian. And I saw recently sales of the book 1984 skyrocketed last year. But it's interesting because, of course, America was not the country that Orwell was worried about. He was worried about the Soviet Union and the potential spillover effects here in Europe. So how did we get here? How did we get to this place where all the things that Orwell worried about are happening in the very country that he was least worried about? How did we get to this situation? Well, I'm a historian, and I appreciate that introduction. Part of my argument is, and I think one of the mistakes people make, is to look at what's going on today in isolation. If we want to address it, we have to understand its historical roots, in part because we have to understand, why are the American people not more outraged about this? I mean, paying $1 billion to Total, and I mean, they're French. Americans hate French, right? I mean, right? I mean, it's really like, if you just stop and think about it, it's nuts, right? And yet, there was no real outrage about the Total deal. Maybe some people just didn't know about it, but there's obviously a bigger story. So what I thought I would do today is spend a little bit of time doing my thing as a historian and talk a little bit about the historical development of science in America. And in particular, this question that has come up repeatedly in the history of American science about the relationship between science and the government. Should the government be funding science? And if so, who should decide what scientists do? These are legitimate political questions, and I think scientists are wrong when they get outraged that anybody would ask a question like that. But also we can see some interesting changing political alignments during the course of this history. And I think understanding those changing political alignments, well, it's always interesting historically. It's always interesting when we see reversals. Like one of my favorite papers I ever wrote is a paper that no one ever read, but it was about how in the early 20th century, math was considered women's work, which is pretty interesting when you can think about all the books that have been written about why women and girls don't like math. I'm like, well, that's not what people used to think, right? So anyway, so we have seen a very significant reversal, and I think understanding that reversal can help us understand why some of these things are happening. And so we can understand both the financial, because there are financial drivers, but also the ideological drivers of the current situation. So I thought I would talk about the history of science in terms of phases or period. Originally I had 4, and the more I thought about it, it came to 6, and then 7, then 8. You know, historians, we're splitters, not lumpers, but I'll do my best not to go into too much excessive detail. So if we look at the very early history of the American Republic, one of the interesting things we see is that ambivalence about science has been rooted in American culture from the very beginning. Now, historians have noted and often emphasized that many of the founding fathers were very engaged with and very inspired by natural science, particularly European Enlightenment savants and philosophers. So there's a lot of reference in Jefferson and his founding fathers to French Enlightenment work, to Isaac Newton. So they're very engaged with science. Most famously Jefferson, of course, but also George Washington, who, little known fact, had a fossil collection. I've always thought if I could ever get out from this climate work, I'd like to write a book. Why did George Washington collect fossils? Like, kind of a cool question, right? James Madison, after he was president, became interested in scientific farming, and he did experiments with horse manure. My students love it. One of their favorite assignments is a paper I sometimes assign that James Madison wrote after he was president on the science of horse shit. I'm not making that up. And John Adams, who was not a scientist, but drew on metaphors from physics to think through the question of the balance of power in the new government. Now, Jefferson wanted the new government to support science. He argued for a Department of Science and for a national university. But he actually lost that debate. A majority of his colleagues felt that science was an elite activity associated with European aristocracy, which they wanted to distance themselves from, And it was not an appropriate target for the public purse in a democratic polity. So if rich people wanted to fund science, that was fine. If they wanted to have societies like the American Academy for Arts and Sciences, which is created around this time, that's fine, but the government shouldn't fund it. And this argument is interestingly carries into the 20th century. So if you ever read my book, The Rejection of Continental Drift, I show how this argument, even still in the 20th century, influenced how Americans thought about Alfred Wegener's theory of continental drift. So these historical roots, they're deep and they carry forward and they influence how people think even about factual questions. So Jefferson loses this debate because the politics of science associates science with elite activities and sees science as fundamentally undemocratic. And I think that's important because I think we still see resonances of that today. And the way Trump tries to align his people against Harvard as an elite institution, as if elite is a bad thing, right? When, you know, most of us would think elite means you've done a pretty good job, right? So this concern carries on, but very quickly things do change, and most of the leaders of the American government come around to having a view that's not the same as Jefferson's, but closest to it. And so very early on, by the early to mid-19th century, we see science being supported by the federal government in aid of trade, expansion, and one has to say Indian removal, and also, though, basic science in support of those other goals. So the first federal support for science is the famous Lewis and Clark expedition, 1804 to 1806. There was a significant scientific component of the expedition, including improvements in navigation, a lot of information collected on natural history, the plants and animals of the interior, and even the search for a living example of the American mastodon, which was tied up in a big debate that was very raging here in Europe at the time about whether animals went extinct. Georges Cuvier played a major role in that. Cuvier thought animals did go extinct. Jefferson thought they didn't, and so he asked Lewis and Clark to find the mastodon in Ohio, and they looked and failed, and Jefferson was very disappointed by that. Cuvier was pretty happy. Okay, 1807, the first federal scientific agency, the U.S. Coast Survey, which is created to map the coast for trade, navigation, and defense. People realize you can't have trade if your ships shipwreck on the coast, and if you don't have good maps, they will shipwreck. So, and this quickly expands to be the U.S. Coast and Geodetic Survey to facilitate inland expansion, farming, mining, and also Indian removal. So there's both an economic and a military component to this. And because of this, the United States emerged as a global leader in certain key sciences in the 19th century at a time when most science was dominated by Europe, France, Britain, Germany. The United States became the world leader in a science that's now mostly forgotten, but geodesy, the science of the shape of the world, geophysics, and also geology, particularly associated with the growth of mining. And many states created state geological surveys. So the idea that this was somehow anti-democratic falls away in the face of these compelling economic and military arguments, but also even some arguments for basic science, like this question about extinction. And so as this happens, the politics shift too. And the anti-elite argument mostly drops away in the face of the economic and military arguments, and also a certain public interest in natural historical questions, like, are there mastodons in Ohio? And how cool would that have been if they had found the mastodon in Ohio, right? Okay, by the late 19th century, this has really expanded, and now there are many major public and private science institutions in the United States. The U.S. Geological Survey is created in 1879 out of earlier topographic surveys, again, very much associated with the settlement of the American West. It's created by an act of Congress, but these questions about public funding of science still remained, and new questions began to emerge about who should be making the decisions about what work was done in these new agencies. So in 1884, something was put together called the Allison Commission. It was a congressional commission that looked at and investigated a set of scientific agencies that now existed, including the U.S. Geological Survey, and making this argument about autonomy. So the scientists in these agencies began to make the argument that once the agency was established and its mission defined by Congress, it should really be up to the scientists to figure out how to implement that mission, because it was only the scientists who really knew how. Congress could decide we needed a geological survey, but it was only the geologists who knew how to do it. And so there was a big fight about this in the 1880s, and a lot of investigation about it, but the scientists more or less won that debate. Out of it came this idea, which has really dominated from then until, for about 100 years, that scientists should really decide what science goes on in federal scientific agencies. It's also right around this time that the first research universities are created in America, so 1876 is Johns Hopkins, and also the first big scientific cultural institutions like the American Museum of Natural History, established in 1869, not just as a museum, a public-facing museum, but also with basic research programs. The museum supported a lot of expeditions, and this leads to both expanding interest in science, expanding knowledge about science, and expanding public support. So these federal agencies, museums, and research universities have a kind of synergistic effect, so that by the early 20th century, most Americans see science as basically a good thing, and see science as something that the public, including the government, should support. It's still seen as basically an elite activity, but an elite activity that has benefits to the broader public. This expansion then takes a step function upward during World War I. Almost everyone knows about the expansion of science during World War II. People know less about World War I, but World War I was actually really crucial, especially the expansion of chemistry. This was a key period for American science because it's the first time that the US government makes a scientific service specifically designed to build weapons. And most people might think it's the Manhattan Project, but it's actually the Chemical Warfare Service. And there's all kinds of fun stories about the Chemical Warfare Service, including Harold Urey, who was the first American to win a Nobel Prize. He won the prize for the discovery of deuterium, the heavy isotope of hydrogen, joined the Chemical Warfare Service because he was a pacifist. He was raised in a religious sect known as the Brethren, similar to Old Order Mennonites. They were pacifists, but there was huge political hostility towards pacifists during the war, and he was afraid that his career aspirations would be derailed, especially if he went to jail as a conscientious objector. But one of his professors told him that if he joined the Chemical Warfare Service, he wouldn't have to fight in the war. And he was originally planning to be a biologist. He wanted to be a biology professor. So he joins the Chemical Warfare Service, becomes a chemist, and then wins the first American Nobel Prize in chemistry. So the course of history is changed by his pacifism. And in later years, he never talked about it. He was actually quite embarrassed by his roots. But one of my former students, Matt Schindel, has written a great biography of Harold Urey. Okay, Chemical Warfare Service was super important for lots of reasons. Obviously, the obvious ones, munitions, explosives, poison gas, but also that a lot of really important materials, particularly glass and high-quality glass for things like telescopes and binoculars and microscopes, all came from Europe, particularly from Germany. So there was a big program to get chemists to help identify and create domestic supplies of key materials. And this did a lot to boost American industry as well. So again, we see this synergistic interaction between science, warfare, and industry. And many universities expanded their programs in chemistry at this time. World War II did for physics what World War I has done for chemistry. I think that effort is pretty familiar to most people, so I don't need to talk a lot about it. Everyone's heard of the Manhattan Project, of course. But it wasn't just the Manhattan Project. The United States created an office called the NDRC, the National Defense Research Committee, headed by Harvard President James Conant. And this organization funded science very, very broadly. There were 5 divisions, and they were focused on specific military concerns, like underwater warfare is the one I've personally researched. But those divisions funded research, physics, chemistry, mathematics, oceanography, marine biology, control systems, and crucially, some of the early years of computer science. Also crucially, the NDRC created the grants and contracts system, which would become the model for federal support of universities after the war, including overhead, which has played such a big role in permitting the expansion of universities like Harvard. And it also created the justification for the National Science Foundation. So up until this time, there had been no system by which the federal government gave grants to individual researchers. So like me as a professor, I could get, well, until this year, I could get a grant from the National Science Foundation, but before 1945, that didn't exist. So the justification was that the war effort had proven how important science was because it drew on a huge body of pre-existing basic science that could then be mobilized towards the war effort. And much of this science that got mobilized had been done at universities. So therefore, the argument became that it was in the nation's interest to support basic science at universities. The fact that the key members of the committee were also university presidents may have had something to do with it also. So the National Science Foundation is created after World War II, and it becomes this giant channel of large amounts of federal support for basic scientific research channeled through universities. And many American scientists think of this as the golden age of American science, and they think that this ran until last year. Well, it may have been the golden age of American science, but it did not run until last year. So what we did see was a dramatic expansion of support for federal science. I've already said that. And as I've said, these grants carried overhead, sometimes as high as 65%. So if I wrote a grant for $100,000, my university would get $165,000, and that extra $65,000 the university could use in any way they wanted. And they would often say it was for electricity, for building repair, for the libraries. Usually, as far as I can tell, it was usually used to hire more scientists who would then write more grants and bring in more overhead. And I actually think that it had a kind of distorting effect on universities, but that's a different talk. Anyway, the argument was then for economic and military growth, and that this would be an engine of innovation that would support economic growth. The politics behind this were democratic with a small d. So Vannevar Bush, who was the architect of the National Science Foundation blueprint, was himself personally a Republican and a fairly conservative guy, like small c conservative, and so were most of the other leaders who were involved in this effort. So none of these people were left-leaning politically, but they did have a kind of little d democratic ideal in that they believed that one of the key things that the National Science Foundation would do would be to help identify talent, and that by spreading money broadly across universities across the United States, this would help identify talent everywhere, and sort of, the rising tide would raise all ships. Not necessarily women and black ships, but Bush wasn't a great advocate of women in science, but he wasn't a great opposer either. And I think that indirectly, the National Science Foundation did, in fact, increase opportunities sufficiently that women and people of color did benefit. Probably not as much as they should have, but they did benefit. Now, the money also flowed disproportionately to elite universities like Harvard, MIT, Princeton, Stanford, but a lot went to public universities too, especially the large flagship public universities like Berkeley, University of Michigan, Ohio State. Now, a lot of attention has been on the NSF because of the way it was framed as kind of by scientists, for scientists, but a lot of money also began to come in from other federal agencies, particularly certain branches of the armed forces. So in my work on the history of oceanography, I look a lot at those additional sources of funding. So billions and billions of dollars now flowing into science. And while there were, of course, tensions during this period, my book, Science and a Mission, goes into a lot of detail about what some of those tensions looked like. Overall, most scientists experienced this as a good thing, and science as an enterprise experienced broad and largely bipartisan support. So there were some arguments about exactly how the NSF should operate. There were Democrats in Congress who wanted to see the money distributed on a geographic basis, and Bush successfully fought against that. But it was still a pretty broad bipartisan consensus. And to the extent that there were questions, they tended to come more from the left than the right. So the NSF gets really going in the early to mid-1950s. By the 1960s, there are questions being raised. And many of the famous student protests of the 1960s were aimed in part at opposing military research on campus. So much of this research was tied to military projects, military agencies, and there was a lot of classified research in universities. And this became the subject of argument. And in 1968, after big student protests, Columbia banned classified research on campus. And it was a very divisive issue, with faculty who received classified research, of course, arguing that it was good, faculty, particularly in the humanities, arguing that it was bad. And at Columbia, some very famous oceanographers actually left Columbia over this issue. So what we see here is that because of these deep military connections and the left-wing critique of them, the political right tended to defend science and tended to defend its relationships to the military, and the Republican Party was, if anything, generally more pro-science than the Democratic Party. It was people on the left who were more likely to raise questions about what we were funding and why. And then we see, though, a big historic change, a real significant shift, even a reversal. And this is what I've written about really in 3 major works now: Merchants of Doubt, my new book, The Big Myth, and an article that Erik and I wrote in Daedalus a couple of years ago. So I want to show you one graph, it's the only graph in the talk, from our Daedalus argument. So this is a graph that shows trust in the scientific community by political affiliation. So Republicans, the solid line; Democrats, the dashed line; and independents, the dotted line. And what you can see here is, if you go back to the early 70s, so this is the period sort of right after the big student protests, right after Columbia bans classified research, you can see that Republicans support science more strongly than Democrats and independents, but there's not a big gap. It's all kind of between 40 and 50% of high levels of trust in science, but more Republicans trust science more than Democrats. And that kind of continues. There's actually a fall in, so this is what I was talking about, there's kind of a fall in support of science or trust in science among Democrats, left-leaning people in the sort of 70s into the 80s. Republican support of science stays pretty stable. And then something big happens around 1992, right around the end of the Cold War. We begin to see Republican support for science declining. We begin to see Democratic support increasing, and there's actually a crossover point in around the year 2000. So basically, we come to the situation where now Democrats support Republicans more, and since about 2010 or 2012, that divergence has grown. So now we see that Republican support for science has cratered, and Democrat support for science has, gone way up. So this big gap. And if any of you do social science research, you know a shift of even 2 or 3% can get you a published article in a social science journal. And now these are shifts of 20, 30, 40%. These are giant social changes, bigger than we generally see. So this tells us that something pretty major happened. And I think understanding this is really key to understanding what's going on today. And it's also key to understanding that this didn't start with the election of Donald Trump, right? I mean, I think the Democrat turn towards science is partly driven by Trump's attacks on science, but we see that whatever the drivers are, they're already in place by 1992-ish. Okay, so what are some of those factors? Well, I'm a historian, so I can never say it's only one thing, but I think we can identify several factors that have combined to drive this change. So, one of them is the politics of the so-called Reagan Revolution. So that's that period right at the end of the Cold War. One of the things that happens in the United States at the end of the Cold War, there are a lot of people on the right who had been arguing pro-market, anti-government positions for a long time, but most of those people had not really been taken seriously by the American people or the mass media. But that changes at the end of the Cold War, when the collapse of the Soviet Union is taken by many people to vindicate free market capitalism. And so you see the advocates of free market capitalism or unbridled capitalism or neoliberalism, whatever you want to call it, they get really emboldened. And they become much more aggressive in their efforts than they had been before, and part of that is getting Ronald Reagan elected. And in our book, we talk about, Ronald Reagan's rise to power and who's behind it, and a lot of it is people he met when he worked at General Electric, which was this super anti-union, anti-government corporation. It's a long, detailed story, and I don't have time to go into it now. But and Reagan attempts to run for president 3 times, and he finally succeeds in 1980, and he runs on a program, an anti-government, pro-market framework in which he repeatedly invokes his favorite catchphrase, the magic of the marketplace. One of my favorite things I ever found in an archive was at the Reagan Library, there are all these speeches where he talks about the magic of the marketplace, explaining American prosperity, explaining Asian prosperity, and of course, it's completely untrue with respect to Asia. Those are not free market policies taking place in Korea at all. But anyway, he uses this phrase so much that one time I found this speech where a speechwriter crosses it out and writes in the margin, cliche. And then a second staffer crosses out the first, puts it back and says, no, RR wants it, keep it in. So, yeah, and we found, I forget the numbers, but I think we found like 20 or 30 different speeches and radio addresses where he uses this argument about just trusting the magic of the marketplace and linking the economic freedom of the marketplace to political freedom as well. And in the book, we go into this argument in much greater detail. And so what does this mean in practice? Well, for Reagan, it mostly means 2 things. Cutting taxes, particularly on the wealthy, based on the argument they will reinvest in the economy and that they know better than the government how money should be spent, and reducing or eliminating regulation. And regulation is a key part of this argument. But what regulations exactly? Because if you think about it, there were all kinds of regulations in the American economy, many of which had been put in place during the Gilded Age or during the New Deal. There were regulations to protect labor, to prevent securities fraud, to prevent speculative and risky banking practices. But the right wing in the 1970s and 80s was particularly concerned about one particular kind of regulation, namely environmental regulation. And they were a set of regulations that had been put in place relatively recently in the late 60s and 70s, including certain key landmark pieces of legislation, the Clean Air Act, 1970, much implicated in attempts to control climate change, and the National Environmental Protection Act, also 1970, which created the Environmental Protection Agency. Before 1970, we didn't have an Environmental Protection Agency in the United States. In fact, most countries didn't. And this really shifted the political landscape to say you had to have that agency, it would make decisions based on science, and those decisions would be legally enforceable. Now, here's the thing. So Reagan was very clear in his opposition to environmental regulation, and again, in the book, we go into quite a bit of detail. But these laws were actually extremely popular with the American people. Gallup polls at the time showed that about 80% of Americans supported environmental protection, even if it cost money, even if it potentially, weakened economic growth, which of course it didn't. That's a false dichotomy, but that's how the Gallup people posed it. So Reagan, and the vast majority of Congress supported these laws too. So Reagan faced this difficult dilemma. He had a lot of pressure from his business supporters, the people who had, paid for his campaigns, to roll back environmental regulation, but politically it was extremely unpopular. So what does he do? Well, he attacks the science that shows the need for the regulation. And this is where science comes into the story and helps to explain why science becomes a target of right-wing criticism and why we see this shift among Republicans who previously had liked, trusted, and supported science to now mostly distrusting and not supporting science. How do we know there's acid rain? How do we know there's an ozone hole? How do we know that climate change is caused by greenhouse gases and deforestation? And I think this is something I do with my students a lot. I say, look, if we didn't have any science, would we know that there was climate change? And especially today, sitting here in Brussels, when it's 36 degrees out or something, you'd say, yeah, it's hot as heck here, and it didn't used to be this hot, right? So we're at a point in history where we can see climate change with our own eyes. we can feel it. We can see how the world has changed around us. But go back to 1980, that wasn't really true. You had scientists saying, this is happening, this is beginning to happen, this will happen, this will almost certainly happen. But it wasn't something you could see with your own eyes yet. So the need to create the IPCC, the need to create the UN Framework Convention, all of these things that took place, and remember, IPCC is created in 1988, that's the last year of the Reagan presidency. UN Framework Convention in 1992, that's when Reagan's vice president, George H.W. Bush, is president, although H.W. Bush was actually kind of okay on these issues, or he's certainly okay by partisan standards. I mean, he looks good in hindsight because everything is gone to heck. But, so you have this period where the scientists are saying either this is a problem or this is going to be a problem, but ordinary people can't see it for themselves. And so that means that if you're making an argument for why you need the UN Framework Convention on climate change, you need science. And without the science, there's no basis for concern, right? It's different now. And the same with the ozone hole. I mean, and I should say, and the other thing is, even if you did know that climate change was happening, so even here today in Brussels, where it's just super hot outside, if we didn't have science, and I asked you, well, what's causing this climate change? You might say, I don't know. You might say, oh, well, it's just a hot summer. I mean, that's what climate change deniers do say, right? Or you might say, oh, the climate is always changing. That's what climate deniers say also. How do we know what's driving the climate change? Science. It's science that tells us that carbon dioxide and methane are greenhouse gases. It's science that tells us, basic chemistry that tells us you burn fossil fuels, you put CO2 and methane into the atmosphere. It's science that tells us you drill for natural gas. Natural gas is methane. So without the science, you wouldn't even know it was happening in the early days, and then later days you'd know it was happening, but you wouldn't know what caused it. And if you don't know what's causing it, you wouldn't know how to fix it, right? So, and the same with the ozone hole even more. I mean, and I've written about this. Without science, we would never have even known there was an ozone hole. But just around now, we would be beginning to see that skin cancer rates were going up, that cows were starting to get weird diseases, that crops were filling, that plants were experiencing sun damage. And we'd be sitting around saying, heck, this is weird, right? What the heck is causing this weird mix of things? And we wouldn't know. But because of scientists, we not only knew, but we actually took steps to prevent it, right? So science becomes the warrant, the justification for environmental regulation. And so if you don't want environmental regulation, what do? You attack the science. You say, we don't really know. We aren't sure. Scientists are just in it for the money, which I'm always like, really? Where's all that money? Right? I mean, right. You make all these accusations against science and scientists. You cast doubt on science so that people will think we don't really know, and therefore, why should we spend taxpayer money trying to fix this problem? There was one ad campaign that ran in the States in the 1990s, around the time Congress was supposed to be voting on Kyoto, said, why would you spend money fixing a problem that doesn't even exist, right? So these very powerful arguments based on casting doubt. Put another way, we can think about these problems as market failures, right? As economists, we would say the external costs that are not internalized. And these were all market failures. I think thinking about climate change or the ozone hole or the public health costs of tobacco, viewing them as market failures is a totally legitimate framework. But the really crucial thing about this history is that it wasn't economists doing economics who discovered these market failures. It was scientists doing science. And in many cases, scientists who weren't even environmentalists. We have a whole chapter in Merchants of Doubt about acid rain. The people who discovered acid rain in the United States, soil chemists, marine ecologists, forestry people. I mean, again, they start seeing these things happening. They didn't set out to study acid rain. They set out to study forest ecology, and they discover these serious problems that are happening. And so because it's scientists doing science who prove that these things are real, science becomes the target of attack. And so in the later 80s and 90s, in this period, well, the chart's not still up there, but these strands come together. So the market fundamentalist or neoliberal ideology that Ronald Reagan has advocating the United States, drawing very heavily on Margaret Thatcher in the United Kingdom, denying these market failures, denying the reality of these problems, because if they accept the reality of these problems, they have to accept that markets aren't magic, or if they are, it's a kind of black magic. And then the resistance, also coming out of market fundamentalists or neoliberal ideology, the resistance to the idea that government needs to play a leading role in the economy. Rather, the neoliberal framework says, no, we should privatize as many functions as possible. We should reduce the government as much as possible. The private sector is more efficient, right? That's a kind of standard argument. And so you see in what's going on today, like, why would you take apart the National Center for Atmospheric Research? My scientist friends all think that the way to defend NCAR is to tell the world how great NCAR is, how great the science is. But that argument won't work because it's not about the greatness of the science. What Trump wants to do is to take the pieces of NCAR that are relevant to weather prediction and sell them off to one of his cronies, and there's actually evidence about this, right? And the same with NASA. He wants to take the pieces of NASA that are relevant for satellite communication and sell them to, guess who, right? SpaceX, right, which just had, I think, one of the largest IPOs in history. Okay, but of course, this is where money comes into it too, right? There are huge economic interests at stake here. And so it's not a surprise that a lot of climate change denial has been funded by the fossil fuel industry and its various cronies, what I like to call the carbon combustion complex. Okay, and then there's one more piece that should be thrown into the mix just for fun, is Trump's weird connections to Vladimir Putin and Russia and their shared interest in drilling oil in the Russian Arctic. When Trump was elected the first time, I tried to get journalists to pay attention to this, and everyone thought I was just being weird and, I don't know, just like barking up the wrong tree. But I asked many journalists I knew, why did Donald Trump ask ExxonMobil CEO Rex Tillerson to be his Secretary of State? I mean, think about that for a moment. I mean, it's a little weird in general to ask a CEO to be a cabinet secretary, but not unheard of, but unusual. But to be Secretary of State? I mean, usually these are people with long records of work in diplomacy. And the interesting thing when this happened, a lot of Democrats and people on the left thought it was good because Trump had appointed so many weird and inexplicable people. At least people said, well, at least he's a grown-up. You know, he's not like a wrecker, right? But what did Rex Tillerson really want, and why Secretary of State? So I'm going to show you a short video clip. Hopefully you can hear it. Sound is often a problem with these things, but let's see what we can do here. So this is a clip from the film version of Merchants of Doubt, so acknowledgement to filmmaker Robbie Kenner and participant media. It doesn't exist anymore, so can't sue for copyright infringement. No, just kidding. I have permission to use this. So here we go.
Top U.S. oil company ExxonMobil and Russia's Rosneft have signed a deal to develop oil and gas reserves in the Russian Arctic.
One of the reasons this deal is now possible is because of the human-induced global warming that has rolled the ice back. It's warmer in the Arctic than it's been in at least 40,000 years. And yet there's ExxonMobil looking at that, thinking they can drill more. The very thing they paid groups to tell us wouldn't happen has now benefited them.
Okay, so that puts the Trump-Putin-Tillerson alliance in a different light, right? And if you think about it, the largest proven undeveloped reserves of oil and gas on the planet are in the Russian Arctic. So if you're an oil and gas company, you would really like to drill there. So what was standing in the way of ExxonMobil drilling in the Arctic? It wasn't the technology, it was American sanctions against Russia. And so as Secretary of State, Tillerson worked to persuade Congress to remove those sanctions. And I didn't follow the details of what happened. They were going to roll them back, but then Russia invaded Ukraine, so it all got real complicated. But it seems to me that what Tillerson wanted, and the reason why he would accept that position, was to roll back the sanctions that would stand in the way of drilling. Tillerson needed Trump as an ally to do that, and Trump presumably wanted Tillerson, the CEO of one of America's most powerful corporations, one of the world's most powerful corporations, as an ally too. So let me wrap up here. So let's bring this now to the present and what we can do about it. I think the scientific community has been very naive about all of this. Even today, scientists will defend science based on how good it is, like I just said, defending NCAR as the jewel in the crown of American science, or to give more scientific information, more data. No offense to my friends at the IPCC, but to make the IPCC reports longer and more detailed. And I think that those efforts are bound to fail because it's not about the science being inadequate. It's actually the opposite. The science is too adequate. The science proves the things that these people don't want to admit. And so the better the science is, the more threat it is. So in the early days of climate science, and again, my team and I have written about this, shout out to Colleen Lanier Richardson, who is the first author on a new paper that it's in press right now, on the history of the Clean Air Act. In the early days, when climate change was still a prediction about the future, there wasn't that much corporate opposition. In fact, we found documents in which the automobile industry in the United States is saying, yeah, this is a real problem. We should probably look seriously at this. We might have to start building electric cars. We have the American Petroleum Institute in the 1960s saying, yeah, this is a real issue. We need to think hard about this. So when it was just a prediction about something that could happen in the future, maybe even probably would happen, there wasn't all that much opposition. But when climate change went from being a prediction to a fact, to something we could observe, and especially something we could observe ourselves, that's when the fossil fuel industry got really down and dirty. And now we're in this moment, as I just said, in some deep way, we don't even need the science anymore. We can see climate change happening all around us, and that's even more threatening. And so that's why the lies are getting bigger, and that's why this administration is no longer just attacking the science, but is also attacking the technological remedies, right? Deliberately standing in the way of the technologies that would enable us to fix a big part of this problem. And so that, of course, then gets back to Rex Tillerson and Trump's connection with the fossil fuel industry, who, as we know, gave him a ton of money in the crucial weeks right before the last election. So my argument is that scientists and the defenders of science have been trying to fight ideology with facts, and that just won't work. Scientists and the defenders of science have also been responding as if we still had that bipartisan consensus on the value of science, and you can understand now why they would think that, because we had it for an incredibly long time. It was a deep, deep part of American history to believe in science, to believe that science helped the country in many different ways, and to believe that public support for science was appropriate in a democracy. But we don't have that consensus anymore either. I'll leave it there and be happy to talk about whatever people want to talk about. Thank you.
Thank you so much, Naomi, for this really enlightening and very rich talk. Thank you for taking us to the history and the historical roots of many of the issues that we would like to address today. I will now open the floor to anyone who'd like to raise a question, make a comment, or share a reaction. The floor is all yours, and we've got a decent amount of time.
Thank you, Naomi. Your conclusion begs for a question. I think it's a trick of you to just extend your time of talking, because you end in telling us that defending science with facts against ideology doesn't work. So where should we go next? What's the strategy if it's not defending facts against ideology?
Well, I like to end with a question because I feel like that's a good pedagogical move, and also because, honestly, I don't entirely know, so I want this part of the talk to be more open-ended. But I think a couple of things. I mean, I think one of the lessons we can learn from history is that the scientists who built science in America in the 19th century had to make the case, right? And they had to go to Congress, and they had to speak to representatives, some cases even, state governments, because it wasn't obvious to people why public money should be spent on science. And I think one of the things that happened in the 20th century, particularly like in the late second half in my lifetime was that scientists just came to take it for granted. They came to assume that they didn't have to make the case because everyone knew how important science was. And I think, looking back now, we can see that that was a mistake. I also think scientists have been, what's the right word here, naive, confused about the whole question of what does it even mean to have a federal scientific agency, and what does it mean to have autonomy? So I've heard lots of scientists say that science should be autonomous, but that can't really be quite right, right? Science should be freed from inappropriate political pressure. We should be free from censorship. The federal government should not be choosing scientific projects based on political ideology. I think it's pretty obvious why that's the case. But the idea that science should be autonomous doesn't really make sense in a democracy. Accountability, political and public accountability, is always legitimate, and the public have a right to ask questions about, what we do and why we do it. And I think that got lost somewhere along the line. And I'll just give one concrete example. My very first teaching job, so I'm, straight out of graduate school, and my husband was teaching in the same department, and he got a grant from the Department of Agriculture. And one of our colleagues criticized him and said that wasn't a good place to get money. And so he asked her why, and she said, first he said, well, where should I get my money? And she said, well, the National Science Foundation. And he said, well, why? Why is NSF better than the Department of Agriculture? And she said, well, the Department of Agriculture is government money. So this weird idea that somehow the NSF wasn't government money, right? And so this idea grew up that the NSF, and I think what she really meant, but didn't have the framework to discuss it, it was really a question about basic science, right? The assumption that because the NSF was being mostly, program directors were themselves scientists, the idea that that was somehow scientists setting the scientific agenda. But that was never really true either, right? Congress has always played a role in deciding what divisions the NSF would have, what the major initiatives would be. And again, I would argue in a democratic polity, that's appropriate, right? So not recognizing that the NSF is government money and not recognizing that it's appropriate for Congress to set standards is all a little weird, right? And so I think scientists have had some strange ideas about how science does operate, should operate, and it's made it hard for them, I think, to distinguish between legitimate political accountability and harassment, censorship, inappropriate political interference. And we're now seeing the second one in spades, but to defend science, a lot of scientists have said things that just don't actually make sense as a defense. Does that help? Yeah.
So I have a sort of fun fact or piece of information that I'd like to share, because I was recently, I went to Boulder twice very recently, and in Boulder there's the National Weather Service, and I went there in summer 2024, and still under Biden, still working, all fine. And then I went back 3 weeks ago, Trump era, and it was completely shut down. And people there are afraid that they will destroy the buildings completely, all the archives, everything, all the machines, everything, so that if, for example, because Congress will be redefined very soon, so that if Congress shifts, if there's a new president in the coming years, science can no longer be continued. So this is to the extent that the situation is at the moment, is that we're going to break things to stop people doing their job in science.
Yeah, no, absolutely. And I think that's another area where some scientists, I don't want to cast too broad a net here. I mean, obviously there are many American scientists who are deeply disturbed by what's happening and understand the potential consequences. But there are other people, I've heard people say things like, oh yeah, we'll get our grants back when the Democrats take over Congress. Well, no, because first of all, it's not clear that will happen for a whole lot of different reasons. But even if it does, if the data sets have been destroyed, if the infrastructure has been destroyed, I mean, if you pull up all these deep ocean observing instruments, you know, are you really going to persuade Congress to now establish the money to put them all back again? And, you know, if I were a member of Congress, I'd say, well, if it's that easy to pull them out and then we pay to put them back, then what does the next administration do? Take them out yet again? I mean, you can easily see how even people who are well-intentioned, even people who would like to see the science restored, may either not be willing or may not be able. And this is one reason why, I mean, it is one argument in favor of international collaboration, which is, again, a reason why the Trump administration hates that. I mean, to the extent that key data sets are backed up in other countries, that's obviously crucially important. And many of these data sets are backed up in other countries, but probably not all of them, right? You know?
Yes, so thank you very much for your presentation. I have just one question, because in my opinion, there's something that's still puzzling me, is that they do attack science very directly, massively, but at the same time, the same actors kind of keep nurturing this imaginary of, you know, AI and traveling to Mars, so this almost Star Wars-ish like world. And so I just don't understand, how do they make this work? Like, it is so contradictory to me, and yet they manage to make this work in public discourse.
Yeah, I mean, that's a great point. And of course, one thing that's hard about any, you know, 40-minute presentation like this, I mean, this is a complicated landscape, and not everyone in it has exactly the same views. But I think one way to understand it is that it's tied to the idea of the private sector being the driver of these things. So many of these people, someone like Elon Musk, I assume, I mean, he can't not believe in science, because none of what he's done or built would be possible without science and engineering. But he may believe that it can be done more efficiently in the private sector. And of course, some of it could. I mean, part of the argument for publicly funded science is that there are many important public needs, many important aspects of the common good that can't easily be privatized because there's no profit motive. And that's most of public health. It's most of environmental protection, right? It's all these areas where the market fails to deliver because there is no short-term profit motive. And it can even sometimes even be in technological innovation where the rewards are not fast enough, right? So, I mean, one of the examples I love to talk about, because so many Americans are either ignorant or being willfully ignorant about the history of tech. But if you think about Silicon Valley, that whole thing, everything we have on our computers, the internet, you know, our phones, the GPS, the private sector didn't build that. The US government did. The internet was invented by the US government in the form of ARPANET. And I mean, it kills me. I sometimes hear these tech executives say, oh yeah, you know, we built the internet. It's like, no, you commercialized the internet. And that's something, you know, and there are aspects of that for which the private sector deserves credit. But the US government built the internet as a communications node or network for military communications. The private sector would never have done that because it was too expensive, too risky, and it wasn't clear what the profit would be. But the federal government didn't care about profit. It cared to make sure that its military communications network were literally bulletproof, right? They didn't want all the communications to be in one place because then they could be taken out by a Soviet hydrogen bomb. But if you had a network with nodes across the country, including in places that the Russians were not likely to bomb, like Salt Lake City in the 1970s, then you could have a protected communications network. That's why we got the internet. And Al Gore did not invent the internet, but what he did do, for which he deserves credit that he doesn't generally get, he wrote the legislation that declassified ARPANET, turned it into an internet, and permitted the private sector to commercialize it, which was huge. So that's a good example of a public-private partnership, but where the public sector took all of the risk. The private sector took none of the initial risk to do that. And there are similar stories to be told. GPS also was invented originally as a military system that then was later made available for civilian uses. And public health, so many areas of public health that the private sector will not engage with will not invest in because there's no profit to be made from it. So, but the folks you're talking about, they don't care about that, right? As long as they get to go to Mars or go to space or whatever they think they want to do, you know, or develop AI for their purposes, they're not worrying about, you know, children in Africa who are getting dysentery, right? And so it's that asymmetry. And then the other piece of it, I think they think that what they need to do can be done in the private sector, that they don't need public sector science. And then I think some of them are, well, I don't know. I mean, I have to be careful here because we're live streaming, and I don't want to be sued for defamation. But my personal opinion is there is a kind of techno-fideist fantasy behind some of these things. I mean, one of the lectures I give in my class is about what does it mean to be realistic, right? Because those of us who support, you know, green energy development will often be told, well, it's not realistic to think renewable energy could meet all of the energy needs of a growing world, especially, you know, if people in Africa are to have, you know, a high standard of living. But then they think it's realistic to go to Mars as a solution for climate change. We don't even know how to get one person safely to Mars and back. So how could we possibly send 2 billion people to Mars? I mean, that's just not even remotely plausible in any realistic framework anytime in our lifetimes. And of course, as Erik Conway, who has written books about Mars, likes to say, and if we did go to Mars, what makes you think we wouldn't just bring all of the problems from Earth to Mars, right? You know? Right. So it's a complicated landscape, but I think that might be part of the answer.
Thank you, Naomi. I'm Sibyl. I'd like to hear you about where is the resistance. Louis started with the resistance. We are facing the same waves in Europe, and we are trying in all sorts of ways to organize some resistance. This is why tomorrow we asked you to talk to business people, because this is where we want you to talk. But where is it in the US? Where do you see it, if you see any? And if not, why is it not there?
Yeah. Well, it's been interesting watching what's happened in the US this last year or two. And, you know, it makes me think a lot about Nazi Germany, right? And why was it that so many people in Germany, a sophisticated country, an educated country, a cultured country, didn't do more to stop the rise of fascism there? And I think one thing that I feel like we've definitely seen in the United States this year is sometimes it's hard to know like what's really a serious threat and what's just the noise. Like this administration in particular, there's so much noise and there's like the outrage of the day. And in many cases, something outrageous happens, but the next day, you know, he says, oh, I was just kidding, or never mind, or, you know, or like the tariffs, you know, huge tariffs, but then reversed. And in some cases, things have been reversed because the courts have demanded it. But in other cases, it just seems like, I don't know, this administration, part of their strategy is to keep people off balance by constantly shifting. So it does make it hard to know what to focus on, and I think that's been a factor. You know, universities have been interesting, mostly disappointing, and you can see the way in which people who are in positions of modest power are clearly desperately afraid of losing the power they have. I mean, I think we've seen that. And it's not easy. I mean, I do feel Harvard has stood up much better than many institutions, and I feel, you know, proud of my university. But even at Harvard, you see the way, you know, huge legal bills are mounting. It's not a trivial thing for an institution like Harvard to defend itself against a sustained attack by the federal government. Not everyone or every institution is in a position to do that, or at least they may not feel they're in a position to do that. So, you know, a lot of it is fear. But I do think a lot of it is not knowing what to do that can be effective. So we certainly have seen student protests, although, again, I think some of them have been misdirected. You know, there's a lot of things. I think one thing that's happening in the United States also, because this administration is so vindictive, a lot of people are working quietly. So a lot of immigrant aid groups are working quietly. They're not advertising what they're doing. And I understand that. I think that's important because I think they need to do what they're doing. But at the same time, if you do it quietly, then other people don't know what you're doing. And so you don't have a sense of a resistance movement. So somehow finding that balance between quietly helping the people who need help, but also standing up and being counted, I don't know how you find that balance. And, this is where I start to feel like I'm on the edges of my expertise. I mean, I'm a historian of science who got pulled into this because I didn't understand why people were attacking good science, right? And I had previously written things about bad science, and I'd criticized bad science, but I didn't understand why people would criticize good science. And that's what led to the whole journey that led Erik Conway into Merchants of Doubt and The Big Myth. And so now we've developed this expertise about, market failure and the ideology that risks acknowledging the failures of insufficiently regulated capitalism. But how do you build a political movement? I don't know. I think you have to invite some other people to answer that question.
Yeah, there's one question here and there, and I'm just going to steal one question
Of course.
as well. Just going back on a distinction that you made towards the end of your talk between the facts and the way that we can sense climate change as happening all around us, and that perhaps piling on more facts isn't going to be enough. Longer IPCC reports perhaps isn't going to be enough either. And so I just wanted to have an exchange on the kind of science that we put behind climate science and whether there is something there in the dominant representations, including from the very legitimate position of climate scientists, about climate change, which is itself a euphemism in a way to describe the kind of destruction of the living, and whether, in addition to the defense of science, as you invite us to do, there's also something to be said about the stories that we tell about climate change and how much resonance that actually has with people. What if we talked about climate change as a social justice story? Would that have more resonance with Trump voters, for example? Would that be something that people could identify more with? It's just an open question. And also how to tread that line as teachers, as researchers, between defending climate science and while remaining critical towards some of the dominant Western imaginaries of climate change and climate science.
Yeah, it's a great question. I think this is where social science research is so important, right? Because I think one thing that we definitely know is, I don't have a blackboard here, I was going to draw a picture, but if you talk to people about 350 parts per million CO2 in the atmosphere, or 420 or 421, what is it today? Most people it's just glaze over because it doesn't mean anything. Almost no one except maybe a few climate scientists have any kind of feeling in their gut of what 421 parts per million CO2 in the atmosphere means. I mean, and most people don't know the difference between the stratosphere and the troposphere. There's a famous, case in the United States, Mass versus EPA, where Antonin Scalia, a justice of the U.S. Supreme Court, in hearing the case versus Mass versus EPA, wrongly referred to the troposphere when they were discussing the stratosphere. And one of the lawyers said, excuse me, Justice Scalia, but it's the stratosphere. And Scalia says, stratosphere, troposphere, that's why I hate these science cases, right? So, I mean, most of us, we don't know the difference, and we don't know why knowing the difference would matter. And so I think, I would say my own personal experience plus social science research, communication research shows you have to make it salient. You have to make the connection that explains to people why this matters to them. And that can be done, but it usually means making it more local, right? And I think one of the challenges of climate science, particularly for the folks who come out of atmospheric physics and chemistry, right? You're thinking about the globe. You're thinking about global change. You're building a model of the whole globe. And the resolution of the model, I mean, I don't know what it is now, but I remember one time years ago talking to a member of Congress. He goes, I want to know what's going to happen in my congressional district. And I'm like, well, good luck with that. I mean, the science just doesn't work on that fine a scale. But you've got to find a way to connect it on a scale that means something to people's lives. And so one thing I do when I talk in public in the United States is give examples relevant to the place I'm in. So I have lots of examples about sea level rise and the billions of dollars in real estate that's at risk, the trillions of dollars in military infrastructure that is at sea level, the airports, there's so much infrastructure at sea level, including like most of the US Navy, right? But one time, and a lot of times I'm giving talks in coastal areas. I mean, most Americans live on the coast. But I was giving a talk a few years in South Dakota, and as I was reviewing my slides a few days before the talk, I thought, yeah, South Dakotans aren't going to give a whit about sea level rise in San Diego. So I spent a day taking pictures of bark beetle damage, which is everywhere in South Dakota. And then I talked about that, and I said, kind of what we said today, said, I don't have to tell you this. You can see it. And one of the really heartbreaking things that was happening, this is a couple of years ago, I assume it's still happening, people were cutting down healthy trees in order to save them, to harvest them before they were destroyed by the bark beetles. And of course, that's understandable, but from an ecological standpoint, it's also a catastrophe. It's what happened to the American chestnut. When chestnut blight hit the United States, people rushed to cut down the trees and use the wood because it was such beautiful wood. But in doing so, they probably stopped natural selection from possibly yielding blight-resistant strains, which do exist elsewhere in the world. So it's an understandable reaction, but it's probably, in the long run, a really bad reaction. But just connecting it to something that people understood. And I think that's something that, if you stop and think about it, it's not that hard, but it's not how scientists are trained. And I say this having been trained as an earth scientist myself, right? We're trained to focus on the general, the universal law, the whole globe, the climate model that tells you what's going to happen if we double CO2, the global climate sensitivity. And we're not really trained to talk to someone about, well, what does this mean for your homeowner's insurance, right? But I think we do need to do that.
Thanks, Naomi.
Yeah.
I had the exact same question of the man over there, so it's already been asked, so I will change my mind. While seeing the curve, a very pragmatic question of trust in science, I was wondering, how do we measure trust in science?
Yeah.
And I'd like to continue and ask you your reaction about the link between those attacks on science that you're actually showing in this curve and the link with a strong democracy and the questions of the fight. I'd love to hear you a bit more about this and the links between those attacks on science, this distrust in science from the politicians, and the fact that it weakens or not the democracy, to which extent.
Yeah. Well, evaluating trust in science is not a trivial thing. And most of the data we have is what I call pretty high altitude. So there are surveys, including one that I participated in, the TIS project, Trust in Science project, led by Victoria Colonia and Niels Miede. Surveys that ask people very general questions, like on a scale of 1 to 5. Sorry, I don't have the slides with me. I just gave a talk 2 days ago where I talked about this. On a scale of 1 to 5, how much do you trust scientists? Where 5 would be, yeah, I totally trust them, and 1 would be like, I never trust them, right? And that's useful, and it's particularly useful because we can compare countries and see how things are different, in the United States, Europe, Africa, whatever. But it doesn't really tell us the basis for people's trust or distrust, and that's harder, and to do that, you need to drill down, and you can't just ask like really broad questions. You have to do more detailed survey work, and that's hard to do, and it's expensive. So we don't have a lot of good studies on that, but that's something that I feel would be really, really useful, social science research, studies where you maybe did focus groups or longer interviews where if someone says, I have a high level of trust in science. I mean, you could do this with surveys too, and actually the Trust in Science project, we've been discussing this. I mean, you can have follow-up questions that say, which of the following comes closer to your belief? I trust scientists because they're not in it for the money. Or why you distrust them? Because they're in it for the money, because there's no sanctions for misbehavior. I mean, you could come up with some plausible reasons. And there is a little bit of evidence. The Pew Foundation surveys in the United States are very good. And they do have some questions that I think speak to trust in science. One that I've been particularly interested in, there's a question they did in a survey about biomedical research, and they didn't explicitly link it to trust, but I think it is linked. They asked, how confident are you that scientists who engage in misconduct are sanctioned? And the answer was not, like hardly at all. I think only like 30% of the people said they thought that scientists were sanctioned for misconduct. I think that's right. I mean, in my own experience, scientists are not generally sanctioned for misconduct. And I think that has consequences for trust. I mean, if I knew that scientists were doing a lot of bad things and suffering no consequences, that would make me not trust them. So I think we do have some evidence about beliefs and activities that bear on trust, but I don't think the connections have been made clearly enough. So I think it's a really important area for better social science. And obviously, because if we don't know the basis for people's trust or distrust, then we don't know what the right ways are to address it. And of course, it's important to say, and I'm not advocating blind trust in science. There are areas of science that are problematic. And so this is another area of my current research, to think about what do universities need to do and research needs to address areas in which we do have evidence of science being corrupted by financial or other interests, because that is for real, it's a real thing. I mean, I've just written about inappropriate corporate influence in pesticide research. I mean, we know that's happening. We have proof of it, and yet the universities involved seem to have done little or nothing to address it. I think Jean-Pascal had a question.
Yeah, hi, I have one.
Oh, okay.
Thank you for your very inspiring talk. My question is about what you called good science at some point. I think this science, even the best science that we could imagine in a way, has foundations that have been stepping stones for this extractivist culture and this also whole system that brought to the destruction of the living and to the rise of fascist ideologies. And so how do we tackle those ontological and epistemological foundations of our good science, quote unquote?
Yeah, that's a great question, obviously a very difficult one. I mean, the relationship between science and extractivist economies is an important one. And I guess the best I can say about that is that I do feel like that has been already changing. And certainly, you know, when I see what my colleagues in earth science are teaching today versus what I was taught in school, there's been big changes. And there's much more conversation among earth scientists now about the role of earth science in extractive industries. That's a conversation that didn't happen at all 30 or 40 years ago. 30 or 40 years ago, it was just assumed that, you know, extractive industries, that's what we did. That's where we went to work. I mean, practically everyone I went to school with went to work for a mining or a petroleum company. So I do think that the scientific community has started a conversation about that, but I think there's much more that needs to be done. And of course, it gets complicated pretty quickly because then it becomes implicated in the history of colonialism, the history of racism, the history of scientific racism. And of course, my field, history of science, has played a big role in trying to have conversations about those issues. And I would say the reaction of the scientific community is mixed. There are scientists who welcome those conversations, who think that, yeah, if science is going to be a productive force going forward, we have to have those conversations and we have to confront our own dark legacies. And then there are also people who are threatened by that. And in a way that recapitulates the larger culture, right? I mean, think about American culture as a whole, or Belgian culture for that matter, right? I mean, there are many of us who feel that having an honest conversation about the history of colonialism, you know, in Congo, for example, or the history of Indian removal in the United States, that these are essential cultural conversations. But they're obviously very threatening to people, and a big part of the attack on DEI in the United States is the unwillingness to have a conversation about the legacies of slavery and Indian removal. So that's probably not really an adequate answer, but you're right. You're right. It's a very important question, and we should be talking about it a lot more.
Thank you, Naomi. Thank you for a very stimulating talk. You mentioned at some point citizen support had an important role in the defense up to a point of environmental regulations. And there are two areas, at least two areas, where maybe this citizen support have received bad influence over the last few years, and that's the changing media landscape with the increasing importance of social media and the algorithm controlled by GAFAM, Elon Musk, etc. And the other one is maybe education. I'm not talking only about higher education and universities like those you mentioned, but also schools, which are maybe also under attack in some countries and in the US in particular. And I wondered if for the resistance, which is one of the subjects of the afternoon, you would have comments on how to maybe shape action around media on one side and around education, maybe with a long-term view, because the small kids of today will be the adults of tomorrow. If you could comment on how that could shape the resistance, maybe help the resistance.
It's hard to know, but I think one thing that seems pretty clear is that everyone needs to be involved, right? A lot of us are very complacent, or we think that political action is someone else's problem. And I found particularly scientists, many people go into science because they don't like the messy world of people and they don't like the messy world of politics. I mean, I can't tell you how many scientific colleagues have said to me, oh, I don't like politics. And I'm like, yeah, well, neither do I, but I still think I need to engage with it. I mean, I don't like Nazis, but I still study their history, right? You know, you need to understand things in order to respond. And I think education is a really good example, because in the United States, a lot of the difficulties we've had around science education have been driven by groups of people who were very motivated and who got elected to school boards, who went to school boards, who tried to influence curricula, who tried to introduce teaching intelligent design in science classrooms. In many cases, they were effective, not because the majority of people in the community wanted that, but because they were more active and everybody else was just assuming that everything was fine. So I think now we see everything isn't fine. And the lesson is that people need to be engaged. They need to be engaged in their communities, their schools. And also, we need to be engaged supporting our teachers. Because I'll, again, give you one personal example. When my children were in school in California, in 6th grade, plate tectonics was part of the 6th grade curriculum. Now, you might think plate tectonics is not politically controversial, but we live in a world where almost anything can be controversial, because the reality is that all science is interconnected, right? And I had written a book about plate tectonics, so my daughter's science teacher asked me if I would come into the class to talk about plate tectonics during the week that they were covering it, and I said, sure. And then she said, yeah, why don't you just send me a few notes about what you'd like to cover. So I sent her a little memo, and it started with, the evidence for plate tectonics, like what made scientists begin to think that this was even a question, right? Well, a big part of the answer to that is the fossil record, right? That people, geologists in the late 19th and early 20th century, had seen that if you look at the fossils in Africa and you compare them to the fossils in South America, you find they're incredibly similar, even though these two continents are separated by thousands and thousands of miles of ocean. And if Darwin's theory of evolution is correct, that shouldn't be. They should be different because they involved in these very different environments, and yet they're the same. And so that was one of the key things that made scientists start to say, well, is it possible that these continents were previously connected, right? So this school teacher said to me, oh, it would be better if you didn't talk about evolution. And I said, yeah, I can't not talk about evolution. And she was pretty worried, and she's a good teacher. I mean, she's a good person. She was trying to do the right thing, but she was clearly coming under pressure and she said to me, yes, some of the parents don't like it. And I said, and so what I said was, well, if the parents complain, call me and I will go talk to the principal. And I will put copies of my books in the library. Whatever it takes, right? But I feel like that's part of the problem. A lot of people just back off. A lot of us are conflict averse. So, here's this teacher. She's a good person, but she's worried about some parents who are going to give her grief. So the easiest thing is just don't talk about it. And I said, but no, you cannot understand this science. And that's not even before we get into the radiometric dating of the seafloor, right? You cannot understand this science if you leave out the evidence that led to this becoming a question in the first place. So we did do it, and no one complained, and it was all fine. But you could easily see how, if I were a slightly different person, if the teacher were a slightly different person, how easy it would be to just say, oh, we'll leave that out. And so now you teach plate tectonics without the fossil evidence, without the radiometric dating. It doesn't actually make sense. So now you have all these kids who have taught a theory that makes no sense. So what are those kids going to think about science? They're going to think science makes no sense. or science is impossible to understand, right? And then I started thinking, well, no wonder maybe so many people think science is impossible to understand. Because if you leave out giant chunks of it because you're afraid of offending someone, it will, in fact, be impossible to understand. So that's just a small example, though, that, you know, if you're a parent, if you have children in school, pay attention to what's being taught. And if it doesn't look right, you know, say something, because other people will say something too, and it will not always be what you would like them to say.
Thank you. I've just been told that we are running towards the end of
I know
our
you had that
seminar.
look, you had that like leaning forward look, yeah.
There's two more short questions.
Okay, and I'll try to make the answer short.
Yes, thank you so much. I'm a big fan of your
Thank you.
work. So one thing that puzzled me, and you have already touched a bit upon that today, but in your talk, you mostly refer to science or to the scientific community as a kind of monolithic actor.
Yeah.
And I wanted maybe you to reflect a bit on that and say, well, actually, it's not monolithic at all. And you have already mentioned also in the history of science in the US, how there are different, waves of science, ways in which science is being funded. Of course, the humanities, the social science, and so on. And so, how does this? How does the fact that science or the scientific community is not monolithic, and I'm just thinking also of science as it is being made in Europe or in China, which is very different than, of course, in the US. And so, yes, what are the implications for what you discussed?
Yeah, that's a great question. I think one of the obvious implications is that, you know, if one science goes down, we all go down. Because I think a lot of scientists, again, have been naive about that. I have heard people, you know, in biomedical science who kind of say, oh, well, yeah, climate science is a target because it's political. But what we do, you know, this is not political. Well, that's ridiculous, right? Because you can see in this whole story, it might begin with certain sciences that are threatening to certain vested interests, but it spreads, right? And that's one thing we've definitely seen in the United States, and you know, even in the time I've been working on these issues. It begins with the tobacco industry trying to defend tobacco, but then they begin to support attacks on science broadly. And you know, we've found connections between all kinds of things that you might not think were connected, like the tobacco industry funding, you know, the Creation Science Institute, because they realize that if they can undermine trust in science generally, then they can undermine trust in the science that they want to undermine. And it also, in some ways, looks less suspicious, right? If the tobacco industry attacks cancer research, well, then we'd say, yeah, of course, right? But if they claim, and this is going on right now with Bayer, and I'm saying this, I hope 1 million people are watching. I mean, the people at Bayer should hang their heads in shame. They have a whole campaign now about trust in science, claiming that they are defending science, when they are the very people who bought Monsanto, who we know corrupted the scientific literature about glyphosate. So we have to stand together and we have to defend all sciences, or maybe not all sciences, but most sciences, right? I mean, we have to defend the principle of scientific inquiry, even while we acknowledge that there can be problematic areas. And I also think we have to talk about social science, right? And this is a little different in Europe than in the United States. Like, you know, in Europe you have Wissenschaft, which includes all sciences, but in the United States, when most people talk about science, they mean natural science, physical sciences. But so many of these questions we've been talking about are really social scientific questions. Why do people hold the beliefs they do? What makes people trust or distrust science? How do you communicate about it in a way that's salient to people? These are not questions that can be answered with more climate modeling. These are questions that can be answered, or at least partly answered, through high-quality, thoughtful social science research. And that's one reason I sponsored Victoria Colonia to come and be a postdoc at Harvard to do this survey work, because it seemed to me we really needed more work of that kind. And I hope we can continue that work, and as I just suggested, and drill down a little more to get a better understanding of how people think about science, you know, if they don't understand it, what is the block, and what kinds of communication mechanisms are effective. And that's not something we can, I mean, personal experience is relevant here, but it's not sufficient, right? But we won't get there, you know. And that's the other piece of it. The scientific community as a whole, I mean, in my experience, some natural scientists are great and understand the importance of social science, but others not so much. I mean, many natural scientists are dismissive of social science. And I one time was with a friend who's a very famous climate scientist in America, good woman, someone I like a lot, but at one point she said something to me about she was worried about money getting diverted into the social sciences. That was the word she used, diverted. And I looked at her and I said, I just want you to know, like, what I do, what all my colleagues do, you could take all the historians of science on the planet, the amount of money it costs to support us, it's not even a rounding error on a satellite, you know? But that's the kind of thing, too, like there's a divide and conquer strategy that, like, we divide us against each other. So super important for social scientists to honor the crucial role that physical science plays, as I said, in identifying the problems, in identifying the causal relationships, but super important for natural scientists to recognize the crucial role that social science plays in helping us figure out how to solve these problems. Oh, one more? Oh, yeah, don't clap yet.
Thank you. Good evening. Chantal Rogeman. I'm a scientist, but I work now for the Belgian government in the climate department, part of the UNFCCC negotiations.
I'm sorry, could you speak up a little?
Sorry. Chantal Rogeman. I'm a scientist, but I work now for the Belgian government in the climate department, so part of the UNFCCC negotiations. So you give a very nice talk about history and how we ended up in the situation we are now. But I wanted to ask you about the future, because what scares me most about the whole Trump issue is that the whole thing has become now so polarized and so politicized that it has become impossible, I think, that there comes a future Republican candidate who actually believes in climate science. We used to have them, as you said in your talk. Some of them were quite reasonable, but it's now become so divided that it has become impossible. So even when we finally get rid of Trump and Trump Jr. and whatever, how do you see it end, and is there a way out?
Yeah, that's a great question. I think it's another example of where we need social science research. And there is research on polarization, although most of the research I'm familiar with is about what causes polarization, not on how you remedy it. So I think that's an area for important research. And I would hope governments would support that, because I think it's in all of our interests in the long run. I think you're right. I mean, it's a very difficult landscape, and I hate the sort of thing where, you know, I'm asked to end on a happy note, so I won't do that, and you didn't do that, so that's good. In America, you're always being asked, you get all these questions about how dreadful, how bad, how scary, and then, oh, but please end on a happy note, you know. But there is one thing that I think could help or could make a difference, and it's what I said before. The American people are seeing climate change everywhere, and including these really costly disasters. Oh, that was one of the other things, I think it was on one of my slides. One of the data sets that the Trump administration has taken down, NOAA had a data set on billion-dollar climate disasters, and that's disappeared. But this is really powerful, right? Because people are seeing these extreme weather events that are causing massive wildfires, massive floods, you know, these astonishing precipitation events, unlike anything we had in our childhood. And these are doing, you know, billions and billions, tens of billions of dollars in damage. And then it's also driving up insurance rates. And in some part of America, you can't even get fire or flood insurance anymore. So I do think there's an opportunity for the right politician to say, this is affecting your life, and this is like you're being robbed, because the fossil fuel industry continues to make historic profits, trillions of dollars, and you're left paying the bill, right? And that, I think, could be a powerful argument for a politician of either party. But if a Republican could do it, you know, that would be an act of bravery and courage that could make a difference. And so, you know, I'm old enough to remember Richard Nixon, who was not exactly a great environmentalist, or a great man, but, you know, we often talk about the Nixon in China moment. No one would have predicted that Richard Nixon, anti-communist extraordinaire, a man that was hated by the left because of his vicious attacks on people, you know, people who were not communists, people who were just left-leaning, but who he tried to discredit as communists. I mean, Nixon in the 50s was a very McCarthyite kind of figure, not someone that was generally admired by, you know, people on the left or even in the middle. But it was Nixon who went to China and created that rapprochement, or whatever the right word was. I don't think anyone, I mean, someone must have predicted it, I guess. But certainly, I can't remember, I mean, what I remember from my own childhood was this incredible sense of shock that no one would have thought that Nixon, of all people, would do that. So there is this sort of power that can come from someone unexpected doing something brave. And even though I think much of what Richard Nixon did was dreadful and terrible, I think his going to China was good. So, you know, maybe that's an out. I do think the Republican Party has painted itself in a corner. I think they know climate change is real, but they don't know how to back out of this position that they've now, you know, dug themselves into so deeply.
Thank you so much, Naomi, and thank you everyone for joining us this afternoon. Let's just have a round of applause for Naomi.